Let's look at another example of integration by parts. The formula is the same. We pick the u value that we want to use by the limit. So of these two functions, we have x and sine x. Notice how the derivatives of either of those are not present. Sure, the derivative of x is 1, but that doesn't help us get rid of sine. So because I have no logs or natural logs, and this is inverse trig, that means like arctan or tangent inverse, we don't have those. That's very uncommon, by the way. We do have the p, though, for polynomial. That's like any x to the third or x or 5x squared plus 7. Any polynomial is another choice for your u. So I'll put my u as x. The derivative, that is 1 in terms of x. This was my u. He is taken. The rest of this is my dv, remember. That's the second part of the formula. So I will write sine x dx. What function has a derivative of sine? Well, that'd be negative cosine, because cosine's derivative is negative sine. We now follow the formula. So we want u times v. My u is x, my v is negative cosine of x. And here is another great instance why we would want this in parentheses. You wouldn't want this to say x minus cosine. It's x times negative cosine. So that's our u and our v, minus the integral of v, that in our case is negative cosine, times the derivative of u. Our derivative of u is 1 dx. This works out really nicely in this case. This is a basic one. That times 1 is going to go away, so it's almost like all we have to derive is this cosine piece. Now I'm going to get this negative constant out front and actually write it as x, negative x times cosine of x. This notation doesn't make anyone think I'm trying to subtract, so I like to write the negatives and the coefficients out front, and generally polynomials out front. This negative 1 in front of the cosine, and of course times 1 as well, I'm going to take that out front as a constant, and a negative times a negative is a positive. I will now be integrating just the cosine x dx, and you can ask yourself, what function has a derivative of cosine? All that uv stays the same. The derivative of cosine comes from sine. So I'll have my sine of x plus c. Once again, you could derive this and see if you got back to the original x sine x, which you should. This would require the product rule, and of course the derivative of sine is cosine. Another example like this in your packet can be found on page 64, number 2, under the integration by parts homework. There's the answer key. You can follow along, but I encourage you to try it and check this if you get stuck.